your public speaking. Cool. All right. So I was gonna make somebody who said yes come up and do the intro to this, but that's all right.
What's the intro?
Today we are starting chapter 5. And we are going to extend our understanding of energy and deepen our understanding of energy, and we're going to zoom in on one particular type. Kinetic energy we've dealt with. We've done the math, at least the introductory math for it. We've done the introductory math for potential energy, gravitational potential anyway. Chemical energy is more complex than we can handle right now. Not than we can, but you guys just haven't learned the stuff needed for it. We are going to focus on thermal energy this chapter. Okay, our entire focus in chapter 5 is on the idea of thermal energy. Okay, what is this referring to? Give me an example of thermal energy.
Blanket.
A heated blanket, I would say we could think of as thermal energy. Any others? Stoves. You guys are all giving me stuff that has heat to it, right? Seemingly. Cool, that's what we should relate it with. So today we're going to start in 5.1, and I would like to name this thermodynamics. That's what I would name it if I got the choice, but I'm going to go with what your book calls it. We're going to be talking, or at least starting to talk about, three main ideas. We're going to talk temperature. We're going to talk thermal energy. That's an awkward space, but that's okay. And the last one is heat. Temperature, thermal energy, and heat is going to be our focus in 5.1. Just so y'all are aware, chapter 5, remember at the end of chapter 5, we're going to do a single large exam, not any larger than normal, but a single true test exam over chapters 4 and 5 together. We will probably have a little bit of time after that to do one more chapter before the break. Okay, so as we look at this, do you guys have an understanding of temperature? Everybody know what temperature is?
Yeah.
Okay, I'm going to give you a second. I want you to tell me what temperature is. Cool. I got two affirmatives. Yes, this is what temperature is. Ooh, love what I heard. I heard somebody say temperature is heat. That's reasonable, except for I've made the distinction in this title that they are different things, Klein. Cool. I'm going to give you about 60 seconds. I'm asking you, imagine there's an alien around you that just can't feel temperature. How would you explain what temperature is to them? Cool. I'll give you a second. And then Ashley, I'll come back that way, okay? Does the perception of temperature matter on the person? Absolutely. I think I probably made the comment, warm soda is the exact same temperature as cold coffee. If you take them both out, they're the same temperature, right? But we say one's hot and one's cold, so there's a weird little thing about it. The way you perceive temperature is completely subjective. Right now, anybody have an idea of how warm it is in here? It's probably about 70. 68 or 70 is my guess. 20 Celsius is pretty standard for indoor temperatures. If we were to all walk to the big gym and I asked the question, how warm is it in my classroom right now? Would it'd be the same? Do you think it'd be different?
Yes.
Yeah.
Well, there's more air over there.
So no, if we just walked out into the hallway right now, and I said how cold or what's the temperature in my room, it's still the same, right?
Yeah.
Does somebody have to be here to feel that temperature for it to exist? So I don't know that we really even need to talk about how it feels, because perception and how we think these are, it's totally subjective. What is hot for me might not be hot for you, or vice versa. Warm, there's a whole spectrum of how you perceive it. Sabrian.
What we said was it's a scale of how many degrees it is outside, or in the environment you're in.
Love that. That's getting a little bit closer. We measure temperature using a scale. And there's two primary scales that get used on our planet by humans. You guys are probably more comfortable with degrees Fahrenheit. Everybody's more comfortable with Fahrenheit. What's the alternative? Celsius. Follow-up question. What's the actual SI unit for temperature? It's not really Celsius. It's Kelvin. Nice job. Okay. Now, looking at this, nobody, and I'm confident of it, nobody is going to have a solid definition of it. Oh, I want it so bad. What you got? Hostile. Okay. As we look at it, turns out this does have a concrete definition that doesn't even matter a little bit about people. Nothing to do with me. Reminder, and I think it was this class, but correct me if I'm wrong. What's everything made of? Atoms or matter. I like matter more than atoms. I'm good with that. And they're all just little particles, right? That are constantly doing what? Buzzing is how I think of it. They're wiggling. Okay. Now, if we think about those particles and impacting temperature, if you heat up a metal, does it expand or get closer together? Okay, so check it out. If my hands are here and they're like barely wiggling, right? If I want to wiggle bigger, do they have to spread out? Yeah. So if I got colder and it started to get together, they would fit together closer, right? And we see that maybe there's a way to explain that expansion and condensing that happens with temperature. It turns out there is, because this has a very specific value that doesn't matter if people are there to sense it or not. If I didn't have any nerves in my body and I couldn't feel hot or cold, I could still measure and tell you the temperature given any scale. Now, as we look at it, it's a kind of big leap and it feels like it's way out there, but I promise that with a little bit of practice and the more we talk about it, the easier it'll get. If something has mass, which there's very few things that don't have mass, photons, light, radiation, doesn't have any mass to it. Okay, I don't know that there's much more that you guys have ever even possibly heard of that doesn't have any mass. Even protons, little tiny bit of mass, but there's mass. Now, as we look at that, everything is made of little particles that have mass, seemingly, that do what constantly?
Buzz.
They buzz, which is just moving. Everything that we ever deal with has a little bit of mass and moves. What sort of energy concerns itself with the mass of an object and the speed at which it moves? We looked at energies yesterday on the quiz or team test. What sort of energy includes velocity or speed, movement? Kinetic energy, right? It's just mv squared over 2. So if everything has mass and everything has some little bit of velocity, even if it's small because it's just buzzing, then they all have mass times velocity we could calculate, which is what sort of energy again, Riley? Kinetic. Check it out. Turns out the temperature, by definition, is the average kinetic energy. Now, all the answers that you guys gave me are pretty good for a different word, but we'll get there. The average kinetic energy of the particles that make up an object. And I'm going to change an object. I'm going to say of the particles that make up matter. Okay, when we talk about temperature, just if it's just us talking about it, if you said how warm is it and you told me, oh, I don't know, 3.8 joules per square meter, that's a weird way to give me the unit, right? Because we've decided that sucks. We have changed it to Fahrenheit and Celsius. I guarantee we have talked about these, but just a quick little check, and I'm going to make a comment first. The higher the temperature, and any objections to me using this as my shorthand? Temp feels natural. The higher the temp, the blank, and I'm just going to leave it blank. You don't actually have to draw a blank on yours. The particles move. Is it, so more or less is a good choice. How about faster or slower? Good. If they buzz faster, we feel that and we interpret that as human beings as the temperature of that object. Every time. As a reminder with stuff, you guys are all pretty comfortable with Fahrenheit, I would guess. Do you feel like you know Fahrenheit a lot better than you know Celsius? Yeah. Okay. At what temperature, and we'll just do a quick review here. Up to you if you want to write it, but I'm going to write it. So let's do temperature. And I'm going to use the scales that Sabrian mentioned a moment ago. Degrees, Fahrenheit, F-A-H-R-E-N.
Does that say particles mover? Or?
It does say mover, but it should say move. I don't know why it says mover. The higher the temp, the faster those particles move. Cool, good call. Okay, for degrees Fahrenheit, it's wonky. You guys say you're more comfortable with it. If you were to take your temperature right now, assuming that you're healthy and not have a fever, what would it read?
97.8.
Your first one was good. 98.6 is kind of the standard. Okay, 98.6 degrees. Do you feel like you are currently 98 degrees? Maybe. It's your organs and stuff should be, or otherwise you'd be having issues. When does water freeze?
32 degrees.
Okay, for Fahrenheit, it is 32 degrees Fahrenheit. What's the symbol for degrees? Little circle. It's not a zero. It's smaller than that. Degrees Fahrenheit is just degrees F. Okay, this is where water freezes. Freeze, and I'm going to write, gosh, what's the chemical? Water?
H2O.
So I'm just going to put H2 up here. We'll do freeze. That's supposed to be a no now, though I'm all goofed up. And then there's another important thing that water does. I don't think anybody else is going to know that number, with the exception of the people that are immediately around you.
Isn't it 212?
It is 212. It's 212. That is bizarre. Now, there's some, whoa, Fahrenheit. There's some cool things that happen here. It matters where you are. If I were to boil water in here, I bet we're about 212. Maybe 211 Fahrenheit today. Maybe. If you were mountaineering or you're at somewhere at high elevation, like I spent a lot of time in Wyoming. If I want to boil water in Laramie, Wyoming, I only have to get the water to like 190 Fahrenheit. Water boils easier at elevation. We'll deal with why, because it's an interesting question. It's a weird thing to see. But this changes. It's not constant. When we talk about the boiling point and the freezing point of water, it is understood that we're talking with 1 atmosphere of pressure, which we haven't talked about pressure in here. How many atmospheres of the Earth are above us right now? Not layers of the atmosphere. How many atmospheres do we have? You're counting the layers, Gian. There's 1 atmosphere above us, right? It's made of a bunch of different pieces that you see in that picture, but there's 1 atmosphere. Is it pushing on us right now? Okay, because air, even though it's really light, it does have mass. They're made of atoms that have mass. Any idea how hard, right now, in a square inch, how many pounds per square inch the atmosphere, just the air around you, is pushing on you? Air is pushing on you right now, for sure, because there's, 500 miles or more, depending on where you want to draw the line. There's a lot of air above us that's pushing down. It's pushing on us from every direction right now, which means if I hold out my hand, it's pushing down, it's pushing up, and we'll go into this to make sense of it because it's weird. 14 pounds for every single square inch on your body is what the air around you is pushing right now. You don't feel it, you don't notice it, because for every moment you've pretty much ever been alive, what has been the air pressure pushing on you? 14, unless you've lived below, way down deep in the ocean, you haven't, or at super high elevations, we don't because people can't breathe there, it always pushes there. Okay, what's a comfortable Fahrenheit temperature? Like nice day, you don't need a jacket, you can wear shorts, but you're not unreasonably hot. 80 or 85 is me sweating and dying already. Just you in general, everybody, it's going to be about the same.
60.
I think 60 is cold, 80 is hot. It's subjective again, right? What's comfortable for you is different. 75 and 80, the difference is 5 degrees.
But how do you measure, okay, that's 1 degree and 2 degrees Fahrenheit. How do you measure it? How do you measure it, in half, in 1 degree? How do you measure that?
I get it. So I could not tell the difference between 76 and 77. I could not.
Yeah, what's the difference?
1 degree.
No, but how do you measure it?
You measure the kinetic energy of the particles. All right, this,
Oh, okay.
did we talk about human perspective versus water perspective?
No?
Oh boy, eyes open. I was gonna get you. Okay, I think of Fahrenheit, somebody fell asleep, doesn't matter who. I think of Fahrenheit as a very human perspective. Now, you can't think about 212 because 212 degrees Fahrenheit is insanely hot unless you're in a sauna. And even then, it's still pretty hot. But, okay. What temperature would you say it's cold? Any colder and you just say it's still cold?
40.
Oh, 40, 30.
40, somewhere, it varies, right? But nobody's at 80 degrees. Anybody down to negative 30?
That's right.
It's cold. Negative 30 is cold, but so is negative 20. It's also just cold.
It's not as cold as you think.
It depends. I would say that about 32 is where I would start to consider it like cold, cold. Now, what's hot for you?
Hot? Oh, 160.
60 degrees? It's
No,
hot in here right now.
112 is where it gets really hot. I've been in a sauna.
Yeah. So interesting, you just complained about individual units and you said and 12. But that's all right.
It's 112, right?
So, sure, I'm fine with that. I'm just trying to give you a hard time. I would argue about 100 degrees is where it gets like uncomfortably hot for me. So about between 30 and 100 is my comfort level. When I try to think of this, I think of, okay, 0% hot is like the end of my comfort level. And that 0% hot happens to be pretty coinciding with where water freezes. The freezing point is cold because we're made of a lot of water. I do not have to get all the way up to 212 to say it's hot. At 100 degrees, I'm about at 100% of my maximum heat. When I think about Fahrenheit, especially with people who have never seen it, think about it as a percent of hot. Like 100% hot, I can't handle it any hotter, 100 degrees for me. 0% hot, super cold, I can't handle it much colder, or if it gets colder, I don't really notice it, is 32. This is a very human perspective. We're gonna not be human for just a moment. Instead of being human, I want you to be liquid water. You are an H2O molecule. What's really, no, we're gonna help you. What's really cold for you as liquid water?
32.
So no, we're gonna jump to Celsius. 0. Why? What happens when there's no hot? Oh my gosh, you freeze at 0 degrees Celsius. What's like the maximum hot you could be as liquid water? I would argue that this system, while it's much less natural for us because we haven't used it, this one makes way more sense just when you think about how you're addressing it. 212 seems arbitrary, 100 doesn't.
Yeah, that's true.
Cool. We will continue this discussion and jump into thermal energy on Monday. Appreciate you guys. Good luck on all your homework that you say you have. I don't know, it's not for me. Algebra, you got like 80 problems. English, that 20-page paper.